Okay, let's talk about an implicit differentiation and what it is. When an equation, right, when a function is written y equal to something, it is considered to be in explicit form. Okay, so anytime you have y equal to something, right, it's considered explicit. This example over here is considered implicit because y is bounded with x. Okay, so y is not by itself, right? You don't have y equal to something. So this is considered implicit. Now you notice this problem though, you can do some algebra work to rewrite it so that it becomes explicit. For example, if we factor out the y, we end up with 1 plus x is equal to x, and then we divide by 1 plus x, we get y is equal to x over 1 plus x. And then now we've rewritten this implicit problem explicitly. Okay? Now all the derivatives that we have been taking, right, prior, the functions were always written explicitly. It was always y equal to something, right? Or f of x equal to something, right? So today you're gonna learn what if we get a problem, for example, something like, let's say you need to take the derivative of 2x to the third plus 3y to the third is equal to 9xy. Okay? I mean, it's probably gonna be very difficult to do some algebra work to get y by itself here, right? You're not gonna be able to do it, or if you can, it's gonna be very difficult. Okay, so when you have something like this, right, that's implicit, right, is there a way to find the derivative of this, right? And that's called implicit differentiation, right? So the method that we're going to use and you're going to learn is called implicit differentiation. So when you have a function that's written implicitly, you can use implicit differentiation to find its derivative. Okay, so implicit differentiation is taking a derivative without having y equal to something. Okay, and that's what implicit differentiation is. All right, so let's take a look at our first example. Okay, let's take a look at our first example here. Okay, now I know that we can rewrite this problem so that it will be explicit, and it's way easier to take the derivative of an explicit function. But for the sake of learning how to do implicit differentiation, we're going to leave the function like this, and we're going to differentiate it, all right, implicitly. All right, so when you have an equation, you can subtract like 5 on both sides, or add 3 on both sides, or multiply by something on both sides. You can do the same thing with the derivative. So for this problem here, if we need to take the derivative, we can take the derivative of both sides. So we're taking the derivative with respect to x. And whatever you do on one side, you have to do on the other. Okay, so let me set this up. So we're taking the derivative with respect to x of x to the third plus taking the derivative with respect to x y to the third is equal to, let me just take the derivative of this right now, that's 0, right, constant. So over here, we're taking the derivative with respect to x of x to the third, right? So it's just power rule right here, we get 3x squared, all right, nothing you haven't done before. Over here, it's a little bit tricky, right? Because we're taking the derivative with respect to x, but we have a y, okay? So we need to take the derivative with respect to x, but we have a y. So the way this works is you have to treat this like a chain rule. Okay, what you're going to do is you're going to take the derivative of the whole, or the outside function, or the whole function. Right, so this is basically just a power rule, or general power rule here, right? Because we have plus 3y squared, and what happens is, remember chain rule, you have to think of this y now as the inside function, right? So now we need to multiply, right, right, the derivative, right, of the inside function. In this case, it's y. Okay, in this case, it's y. So we took the derivative of the whole function, right, and we got this. And then chain rule says now you need to multiply by the derivative of the inside function, remember? So the inside function is y. So when you take the derivative with respect to x of y right here, that's going to give you dy dx. Alright, you need the dy dx. Alright, so let me rewrite everything. This is going to be 3x squared plus 3y squared times dy dx is equal to 0. Alright, so here's what you need to remember. Alright, I showed all the work here. Okay, I'm not gonna show it in future examples. So what happens here is anytime you need to take the derivative with respect to x of something with y, right? Anything with a y, you have to have a dy dx. You have to end up with a dy dx, alright, on account of the chain rule. Okay, so that's the key you need to remember. Anytime you're taking the derivative with respect to x of something with y, you have to end up with a dy dx. Okay, so now we need to solve for dy dx. Right, we need to solve for dy dx. So we need to get this by itself somehow. So here's where all the algebra comes into play. So we're going to subtract 3x squared on both sides. We get 3y squared times dy dx is equal to negative 3x squared. And then we divide by 3y squared on both sides by 3y squared. These divide out. So then our answer, we end up with dy dx is equal to, these divide out right here, we end up with negative x squared over y squared. Okay, so the derivative of y with respect to x, right, is equal to negative x squared over y squared. Okay, negative x squared over y squared. Right. So that's how you do implicit differentiation. Alright, the key is to remember this part right here. When you have to take the derivative with respect to x of something with y, right? You have to remember the dy dx. Alright, so this part right here gives you the dy dx, and that's on account of the chain rule, because you have to treat this as a chain rule. Okay, let's take a look at another example. Let's see, we have 3y squared plus sine of y is equal to 4x to the 5th power. Okay, so something here like this, obviously we're not going to be able to rewrite this so that y is by itself, so this is considered implicit. There's no way we can rewrite it to make it implicit. I'm sorry, there's no way we can rewrite it to make it explicit, right? This is implicit. So that's why we need implicit differentiation. So to take the derivative of this, right, we'll take the derivative with respect to x. Whatever you do on one side, you do on the other side of the equal sign. So the derivative with respect to x, 3y squared plus the derivative with respect to x, sine y is equal to, and this, since I'm taking the derivative with respect to x of something with x, let's just do that right now. That'd be 20x to the 4th. Okay, 20x to the 4th. Alright, so right now we need to take the derivative of this right here. So we take the derivative of okay, so right here we're taking the derivative with respect to x, right? And you notice of something with a y, right? So we're going to do the general power rule here. So 6y, right? And since we have, right, something with a y, you need the multiply times dy dx. Okay, over here also we have plus. So we're taking the derivative of sine of y. So the derivative of sine of y, well, the derivative of sine is cosine of y. And then since we're taking the derivative with respect to x of a y, right, something with y, you need the what? You need the dy dx is equal to 20x to the fourth. Okay, so now it's just all algebra. Remember, we need to get dy dx by itself. So you have to notice here, oh, both of these have dy dx in common, so we can factor out a GCF, which is dy dx. So then we'll end up with 6y plus cosine y is equal to 20x to the fourth. So now to get this by itself, we divide by 6y plus cosine y divided by 6y plus cosine y. Right, there we have it, dy dx, right, is equal to 20x to the fourth over 6y plus cosine y. Okay, and don't forget what you just found here. This is the, what is this? This is the equation to find, alright, the slope of the tangent line, right, to the curve at a specific point. Okay, so don't ever forget when you're finding the derivative, you find the equation, alright, to find the slope of the tangent line at a specific point. Right. Let's take a look at the next example. Alright, so let's implicitly, alright, derive this. So I'm going to take the derivative with respect to x on both sides, the derivative with respect to x. So d dx 3x squared minus d dx y squared is equal to, I'll just take the derivative of this constant, which is 0. So over here we're going to end up with 6x. Okay, and then we have minus, now we're taking the derivative with respect to x of a y, so you know what needs to happen, right? So we have a general power rule here, 2y times, and then we need the dy dx. Okay, anytime you're taking a derivative with respect to x of something with a y, you have to multiply by that dy dx. So equal to 0, and the rest of it's real simple algebra work, right? So we need to get this by itself, so let's subtract this 6x. So negative 2y times dy dx is equal to negative 6x. So we divide by negative 2y on both sides. This is gone, so then we end up with dy dx is equal to negative divided by negative is positive, 6 and the 2 reduce, so we end up with 3x over y. Okay? Okay, let's take a look at a more challenging example here. Alright, so we're going to take the derivative with respect to x, right here, both sides. So we're going to implicitly derive this, the derivative with respect to x, the derivative with respect to x. So we end up with d dx of cosine y minus d dx sine x is equal to the derivative with respect to x of sine y minus the derivative with respect to x cosine x. Right. So let's work these out. So the derivative with respect to x, cosine y, so we have a y here, right? we're taking the derivative with respect to x of y here, so you have to be careful. So the derivative of cosine right here is negative sine, right, of y. And then, since we're taking the derivative with respect to x of something with y, you need the dy dx. Okay? And then over here, the derivative of sine x, we have an x here, so that's perfectly fine. So the derivative of sine is cosine x, right, is equal to, over here taking derivative with respect to x of something with y, so what's the derivative of sine? We end up with cosine of y. Alright, but since this is y here, we need the dy dx. Right. Plus the derivative of cosine right here. Oh, I'm sorry, not plus. Minus the derivative of cosine right here, right, which is going to be negative sine of x, which eventually the negative becomes plus. Okay. So now what's our goal? We need to get dy dx by itself. So you notice this term here and this term, we need to get them on the same side. So then we can factor out the dy dx. So I'm going to move this over here. I'm going to move this over here. Alright, so let's do the algebra. So I'm going to subtract this value on both sides. Right, and then I'm going to add this value on both sides. So then, so I'm adding cosine of x on both sides, right? So I'm adding cosine of x. And over here, I'm subtracting this value right here, negative cosine of y times dy dx. So I'm doing this to both sides. Okay, so that way this cancels and this cancels. So we're going to end up with negative sine y dy dx. And then since I subtracted this on both sides, I'll have minus cosine y dy dx is equal to, alright, remember I added cosine to both sides right here. We have sine of x plus cosine x. Okay, now that these are on the same side, we can factor out, right, we can factor out the dy dx. And then we're left with negative sine y minus cosine y is equal to sine x plus cosine x. And then last step, we need this by itself, so we're going to divide by this value, divided by negative sine y minus cosine y minus cosine y. That's gone. So we get dy dx is equal to sine x plus cosine x all over negative sine y minus cosine y. Okay? Let's take a look at another example. So we have square root x plus square root y is equal to y squared. Okay? So implicitly deriving this, we take the derivative with respect to x on both sides. So d dx of, let me change this, so this is x to the 1/2, right? Plus d dx y to the 1/2 is equal to, over here, d dx. We'll work with that. So over here, this is going to give us power rule, so we end up with 1/2 x to the negative 1/2 power. Okay? Plus, and over here, we're going to use the general power rule, so we end up with 1/2 y to the negative 1/2 And then since we have a y here, right, we need the what? dy dx. Okay, is equal to, over here, oh, another y, so we take the derivative of the whole function, or the outside function. That's going to give us 2y times dy dx. Alright, so let me rewrite these negative exponents. So this would be 1 over 2x to the 1/2 plus 1 over 2y to the 1/2 times dy dx is equal to, this gives us 2y times dy dx. Okay, so now we need to get these on the same side. Okay, we need to get these on the same side right here. So what I'm going to do is I'm going to take this value here, right? Here's where the algebra comes into play. I'm going to take this value here and subtract it on both sides. Okay, so if I subtract, alright, this, if I subtract this right here, right? So 1 over 2y to the 1/2, right, times dy dx, this value, that'll cancel that. So I'm going to subtract right here, right, 1 over 2y to the 1/2 times dy dx. Right. So the reason why we do this is, now that we have the dy dx on both sides, you can factor it out, right? You can factor it out. So over here I'm left with 1 over 2x to the 1/2 is equal to, I'm going to take out the dy dx, alright, factor it out, and then I'm going to end up with 2y minus 1 over 2y to the 1/2. And then to get this by itself, we're going to divide by this. Divide by 2y minus 1 over 2y to the 1/2. So divide by 2y minus 1 over 2y to the 1/2. Okay, and then we need to continue the algebra here. So we've gotten dy dx by itself, right? So we've gotten dy dx by itself, so that's good. But you need to further simplify this, right? So this I'll change to radical form. This is 1 over 2 square root x. Okay, and then in the denominator right here, I have 2y minus 1 over 2 square root y. I'll change this to a square root. So we need to get common denominator here, so I need to multiply over here by common denominator, which is going to be 2 square root y. So 2 square root y over 2 square root y. So then when I multiply this and the denominator here, I'm going to end up with 2 times 2 is 4. So we get 4y square root y minus 1 all over our common denominator, 2 square root y. Okay, so I've simplified this right here to get this. And then you need to, we're working with a complex fraction, so we're going to take the numerator and multiply it by the reciprocal of this. Okay, so I'm going to take the numerator, 1 over 2 square root x, I'm going to multiply it by the reciprocal of this, so that would be 2 square root y, that moves at the top, and we have 4y square root y minus 1, okay, is equal to dy dx. Okay, and then this is, I mean, you can multiply, clean this up a little bit more if you want, but none of these are really like terms or anything like that, or so you can't really combine anything, so you just leave it like that, that's fine. Okay, and that's our derivative dy dx. And let's see, so let's take a look at an example that's going to require quotient rule. Alright, now I know this example we can multiply by x minus y on both sides and then rewrite the problem so that it's explicit, so that we have y equals something. But for the sake of practicing implicit differentiation, we're going to leave it like this so that we can derive it implicitly. Okay, so we're taking the derivative with respect to x. So we're going to set up our quotient rule. So low d high, so low, and then the derivative with respect to x of the high function, which is x plus y, minus high d low, x plus y, and derivative with respect to x of, alright, so we have x minus y all over, right, our denominator, right, which is x minus y squared. And this equals the derivative of 3 is 0, right? So this, first of all, this makes it nice because if you multiply by this on both sides, this is 0. So basically our denominator we don't need to worry about, because when you multiply by this on both sides of the equal sign, this will divide out, and this times 0 will still be 0. So all we really care about is working out the numerator. Okay, so then now we have right here x minus y, the derivative over here, so we're going to end up with the derivative of x, right? So we have this, I'll put parentheses, the derivative of x is 1, right? And then the derivative of y right here, the derivative of y is going to be 1. And then remember, we're taking the derivative with respect to x of y, need that times dy dx. Okay, minus, we have x plus y, right? And then we have times the derivative with respect to x of x, that's going to give us 1, minus the derivative with respect to x of y, that's going to give us 1, but times, we need the dy dx because that's a y, dx is equal to 0. Alright, so then now let's simplify this right here. So basically we have x minus y times, now here's where we have to be careful, like follow the order of operations here, right? Don't add the 1 and the 1 here and tell me that gives you 2, right? Because you have 1 plus, this is 1 times this, so 1 times this is just this, so we have 1, right, plus dy dx. Alright, so be careful with the algebra there. Minus x plus y, and same thing, same idea here, right? 1 times this is just dy dx, so we have 1 minus dy dx. Okay, so don't ever forget about order of operations. And then you should recognize what you need to do here, right? You need to FOIL this, alright? You need to FOIL this right here. So x times 1, that gives you x, and then we get plus x dy dx. Right, then negative y times 1 gives you negative y. Negative y times dy dx gives you negative y dy dx. Alright, same thing over here. Now here's where you have to be careful with the algebra again. You're subtracting this value. So we're going to FOIL this first, right? We're going to FOIL this first. So we have minus. Put this minus right here. And then we're going to FOIL all this. X times 1 is x. X times negative x dy dx. Then we have positive y. And then we have negative y dy dx. Okay? And then we're going to distribute the negative, right? So here's where the algebra is really important. We have to FOIL this first to get this, and then distribute the negative, right? So we get negative x, all right, positive, we're distributing the negative, negative x, positive x dy dx, and then negative y, and then positive y dy dx. All right, and then we have all this over here. So let's look and see what happens. All right, remember we combine like terms now. We're combining like terms. Oh, the x's here, right? They cancel each other out. Right, let me do that in green now. Positive x, negative x, that's gone. So that's nice. What else? Oh, this right here. Negative y dy dx, positive y dy dx. That's gone. All right. So all that we're left with is we have x dy dx, x dy dx. Those are like terms, so you have to combine like terms. Okay, so this is a great problem with a lot of Algebra 2 skills in it. So we have 2x dy dx, right? And then negative y and negative y gives you negative 2y is equal to what? All this is equal to 0, okay? So we're almost done. Remember, our goal is to get the dy dx by itself, right? So be careful with the algebra still. We're going to add this value to both sides. 2x dy dx is equal to 2y, and then we're going to divide by 2x. So we get dy dx is equal to divide out y over x, right? And that is your derivative, all right? So the derivative of y with respect to x is equal to y over x, okay? Y over x. And don't ever forget, what did we just find? We just found the equation to find the slope of a tangent line at a certain point, right? All right, to this curve right here, okay? So great problem with lots of algebra in it. Okay, let's take a look at one last example. Let's say we're given a curve 3xy plus 2x to the 3/2 power y to the negative 1/2 power is equal to 28. And so given this function, let's say we need to find the slope of the tangent line. So we need to find the slope of the tangent line. At 4, 1. Alright, at the point 4, 1. Okay? So in order to find the slope of the tangent line, you need to find the derivative of this. Okay, and obviously this is implicit, so we need to use implicit differentiation. So let's take the derivative with respect to x of both sides. So we're going to end up with, so right here, when I'm taking the derivative of this, you guys have to recognize that this is going to be it's going to require product rule. Right, so I'm going to take the 3, I'm going to pull it to the front. Right, then I'm taking the derivative with respect to x of x times y. Right, so here's our first function, our second function. Okay, over here I'm doing it's the same idea. So we have plus, I'm going to pull the 2 out to the front, and then I have the derivative with respect to x of x to the 3/2 times y to the negative 1/2 is equal to derivative of 28 is 0. Okay. So now our product rule here, let's set this up, our product rule. So we have, product rule says this is our first function or second function. So right here we get the derivative of x, which is going to be 1, times our second function, which is y, plus our first function x times the derivative, right? The derivative of our second function, right? The derivative of y is 1. Okay, but since we take the derivative of y, we need the dy dx. Okay, so all this right here. And then here's where you need to be careful. So we have 1 times y, which is just y. Over here we have x, right, times 1 times dy dx. So this is going to give us positive right here, x dy dx. And then don't forget the 3. So we distribute, we end up with 3y plus 3x dy dx. Okay, so I've just derived this part right here. Okay, now we'll move on to this. So we have the plus 2 right here, and then I'm going to set up all this right here. So this is our first function, second function. So product rule says I take the derivative of this, right? And this is an x, so it's just, you know, power rule. Minus 1, so 1.5 minus 1 will leave you with a half. Times our second function. Plus, right? And then we have our first function. times the derivative of the second. So we have a general power rule here, a general power rule. So we have negative 1/2 y to the negative 3/2, right? And then since we took the derivative with respect to x of something with y, right, we're going to need the what? We need the dy dx. Don't forget that. So let's clean up this right here. So we're going to end up with this right here. We have the positive 2 out here. We have 3 over 2 x to the 1/2 y to the negative 1/2 plus, then over here we have this negative right here. I'll move it over here. Negative 1/2 x to the 3/2 y to the negative 3/2 dy dx. Alright, now if you distribute the 2, right, into here, right, these are going to divide out. So I'm going to end up with plus 3x to the 1/2 y to the negative 1/2. Then when I distribute the 2 over here, I'll end up with negative, the 2's divide out, x to the 3/2 y to the negative 3/2, right, dy dx. Okay, and then now we need to get the dy dx's alone so that we can factor them out, right? Remember, all this is equal to 0. So what I'm going to do is I'm going to keep this term here and this term here because they both have a dy dx. We need them here so that we can factor out the dy dx later. So I'm going to move this right here, and I'm also going to move this to the other side of the equal sign. So I'm going to subtract 3y, and I'm going to subtract 3x to the 1/2 y to the negative 1/2 to the other side of the equal sign also. I don't have space, so I'm just going to say it. So what is that going to leave us with? That is going to leave us with, we just have this 3x dy dx minus x to the 3/2 y to the negative 3/2 dy dx is equal to, we end up with negative 3y minus 3x to the negative, positive 1/2, and y to the negative 1/2. Okay, and then our last step, well, pretty much, dy dx, we factor it out from these two terms. So we end up with 3x minus x to the 3/2 y to the negative 3/2. Okay, and then it equals this, right? So what we're going to do is we need to get this by itself, so we're going to divide by this value on both sides. 3x minus x to the 3/2 y to the negative 3/2. So we're going to divide over here 3x minus x to the 3/2 y to the negative 3/2. So these divide out. So our equation, right, the derivative of y with respect to x is equal to negative 3y minus 3x to the 1/2 power times y to the negative 1/2 power all over 3 times x minus x to the 3/2 power and y to the negative 3/2 power. Alright, so this is our equation to find the slope, right? This is our derivative, meaning this is the equation to find the slope of the tangent line, right, to the curve at a specific point. And the point that they gave us was 4, 1. So here's your x and your y value. Right? Here's your x and your y value. You're going to plug these in here to find the slope. Okay, so to find the slope now, we have negative 3 times 1 minus 3 times 4 to the 1/2 power times y to the negative 1/2 power all over 3 times 4 minus 4 to the 3/2 power times 1 to the negative 3/2 power. Alright, so we're going to evaluate this. So we're going to end up with right here, negative 3. And over here, 4 to the 1/2 power, this is the square root of 4. So the square root of 4 is 2. Negative 3 times 2. Over here, this 1 to the negative 1/2 power, this is really just 1. Right? So negative 3 times 2 times 1, we get negative 6. Right? So that gives us negative 9 in the numerator. On the bottom, we have 3 times 4, that's 12. Minus 4 to the 3/2 power, that's the square root of 4. Right? Square root of 4 cubed. Square root of 4 is 2. 2 cubed, that gives us 8. Right? And 1 to the negative 3/2 power, that's just 1. So we have 8 times 1 right here. Right? So 8 times 1 is 8. So 12 minus 8 is 4. So our slope, right, at the point 4, 1 is negative 9 over 4.